Namaste everyone. In this video, we'll be solving a problem on kinetics. So we have a weightless and frictionless pulley here, and there is an inextensible string moving from the pulley, and we have W1 and W2, the two masses hanging from it. W1 is greater than W2, hence it's going to be moving downwards, and W2 will be moving upwards. We have been asked to find the formula for acceleration and tension. Of course, both will be moving with the same acceleration, only the direction being different, and because the pulley is massless and frictionless, the tension that exists in the string on both the sides will also be equal. Now we'll have to take the free body diagram of each block one by one. Let's put all the forces acting on this. Upward force is the tension. There will be a downward force equal to weight. This one is for W1, and because the acceleration for this particular block is downwards, the inertia force will be acting in upward direction. So these are all the forces acting on the object. So when you take sigma V for this, because we have applied the inertia force, we can consider this object in equilibrium, and the sum total of all the forces will be equal to 0. So let's find all the forces. T is acting upwards. Fi, the inertia force, is also acting upwards, whereas W1 is acting downwards. So sum total has to be 0. Tension is not known. Inertia force is mass into acceleration. Now weight of this is W1. So if weight is W1, mass is W1 by G. So this needs to be multiplied with acceleration to get the inertia force minus W1. So this is our equation 1. So let's just rearrange this equation such that we get the formula for T. So W1 goes on the other side, becomes positive. This one becomes negative, and this is the equation that we get. Next, we need to take the free body diagram of the second object. Once again, put all the forces on this. The upward force acting here as well is T. The downward force that's acting, this is W2. And since the acceleration for this object is acting upwards, the inertia force will be acting downwards. Once again, we have to apply the equation of equilibrium, the sum of vertical forces. So T is acting upwards, positive, W2 is downwards, minus Fi, because Fi is also acting downwards. The sum total has to be equal to 0 because we have applied the inertia force, and by D'Alembert's principle, the object will be in static equilibrium. And let's now substitute whatever values we know. Tension T is T itself minus W2, and inertia force for this particular object will be mass, that is W2 by G, into the acceleration that it is undergoing. Let us now also substitute the formula for T, which is here. Let's take this over here, and remaining quantities will remain as it is, W2 minus W2A by G. So this total will be equal to 0. Now let's take both the acceleration terms on the left side, which will give us W1 by G plus W2 by G. A comes out as common, and on the other side we are left with W1 minus W2. So the acceleration formula will be G times W1 minus W2 divided by W1 plus W2. So this is the formula for acceleration. Now, substituting this formula back into the formula for tension, we will get the formula for acceleration. So that is W1 minus W1 by G into K. So into G times W1 minus W2 whole divided by W1 plus W2. So simplify this, G will get cancelled, and here we get W1 times W1 plus W2 minus W1 times W1 minus W2 whole divided by W1 plus W2. So when we expand the brackets, what happens is W1, the W1 square minus W1 square will cancel, this minus to minus becomes plus, so we get 2 times W1 W2 in the numerator and W1 plus W2 in the denominator. So this here is the formula for tension in the string. So that's what we have been told to find. That's it for this video. The next one will take up another problem. Hope you have understood this. If you have any doubts about this, you can let me know in the comment section, and see you until the next one.